Evening all. Hope this works out as planned. It's a bit of a first, but there you go. And because it was going to be later on, right at the end of the month, and I hadn't started the prep for this one. It's been a bit rushed, but I think it should be okay. More on HF antennas. It's a sort of follow up and overlap to what Roger did last year. Some of you might not have experienced that, so right, what we're going to consider here, half-wave horizontal dipole, which is really the starting point for everything. And then two half-waves or a full-wave horizontal dipole. And dipoles of other multipoles. A bit about multi-band dipoles, fan dipoles, and other stuff. And touch on other things and a tiny bit on verticals. I came to the conclusion there's a vast amount here, so I'm going to be skipping over some of it. And if people want to know more about certain specifics, rather than having a lot of discussion tonight, I can sort of do a little mini thing on the back of some other event at the pub, at the hall or whatever, elaborating on any particular topic. So anyhow, we press on. Right. Classic half-wave dipole, generally center fed. Very often we feed it with coax. Since the dipole is a balanced device and coax is unbalanced, preferably with a balun, sometimes fed with an open wire feeder. There's also briefly going to be considered the off-center fed dipole, sometimes rather incorrectly known as a Wyndham, and the end-fed half-wave, which classically these days it's becoming more popular, is fed with a 49:1 impedance ratio, unbalanced to unbalanced transformer. That's the Bible I go back to sort of borrow some words from an ancient lager advert, possibly the best antenna book for basic theory and that. That's my 1961. I previously had a 1949 one and wished I hadn't sort of passed it on, actually, because there was some stuff in there that I think's been dropped. So if you ever stumble on a version of that available secondhand for not very much, recommend it. Right, and pinching out of that, polar plots and diagrams, which is a sort of area that Roger spoke about, different antennas and mounting them and feeding them and impedances, but he didn't really cover polar diagrams, other than the fact that verticals have low angle, etc. Right, convention is to show the horizontal polar plots as viewed from above, which I dubbed drone view to use a bit of modern thingy in it. So that's telling you which direction around the compass, where the lobes are and all that. The vertical radiation pattern or plots also needs to be considered from two directions in line with the wire and also broadside to the wire, because they're different. Conductivity to the earth is a significant thing in practice. All the textbook stuff start with perfect earth and how much is included with typical earth or isn't. It gets a bit sort of grey, but these days, if you're into the PC modelling stuff, you can select no earth, perfect earth, and typical earth. Anyhow, Tom said, these are the. Can you see that? Is it all wonderful? Yeah, right, marvelous. They're the PDFs that weren't initially coming through. Don't bother about the small print. That is your classic half-wave dipole. The theoretical figure of 8 with very, very sharp nulls is how it is when it's way up in the sky in free space. This is showing the three things at three vertical angles, 9, 15 and 30 degrees pointing up. That's gain over a perfect earth, I think. And you'll see the by the time you get to 30-degree elevation, it's almost an oval. The steep nulls disappear, and certainly when we have antennas at modest heights, you don't see the nulls. Anyhow, one wavelength, 2 halfways, and broadside on, we do have some quite substantial nulls, but it's a 4-leaf clover. Step on 3 halfways, 1.5 wavelength, and you've got a narrowish lobe broadside with a bit of gain possibly, and fatter lobes sort of almost 45 degrees off around. And you'll find as you step up each half wave, the pattern changes to nulls and peaks. So well, that one, does it show my, yes, that's the one I just showed. And there's 3 wavelengths and there's 2 wavelengths. So all the lobes start multiplying up. So when you've got to take an extreme case, a 160-meter dipole, and you're trying to operate 10 meters, it's like a, and there's 4 and 5 wavelengths. Pattern, that is a fairly critical, depending on, that dictates sort of the skip distance you're going to achieve, and you know where you want to place your transmit power, as well as the compass direction, you know, where, how far away. If you want NVIS, near vertical incident sky wave, which we quite often do for 40 and 80 into G and close to Europe contacts, then as the TX fans would put it, we have a lowish horizontal dipole, and which is described as a sky warmer. Exactly the opposite if you're trying to work the great DX. You want to radiate as near to straight out to the horizon as possible, and that's either horizontal antennas way up in the sky, or go for a vertical. Vertical plots. First one at the top here. Yeah, there we go. That's horizontal half wave antenna at a 1/4 wavelength above ground. This top left hand one is the I don't know if you can see my mouse pointer, but yeah, right, good. That's down the wire, and that fatter looking sky lobe is down the length of the wire, which makes perfect sense. If you have roughly a half wavelength, you ain't got much going directly up, and then the down the bottom is 3/4 of a wavelength high, where you've got sort of a big fat lobe going up, but you've also got some low angles, so you've got a bit of DX and NVIS. I'll be talking again about the possible situation with regard to if you've got something half wave above ground, and you want NVIS, you ain't going to get too much, although again these are over a perfectly conducting ground, and in reality a lot of us have inverted V's or something, and I suspect that middle pair, if you've got a bit of a bent wire, inverted V fashion, I expect a lobe will pop up out the middle. Those who play with computer modeling, which I don't at the moment, would know better than me. Again, as you go different multiples, you've got this business of the straight up vertical lobe comes and goes with multiples. Right. Impedance of a half-wave dipole, which is fractionally shorter than a physical half-wave due to end effects and things, which I won't go into. Just slightly shorter. Fed in the middle is, in theory, 72 ohms, but that's the free space situation. And if you're talking 40, 80 meters, most of us don't have 200-foot towers, etc., or bigger. So that theoretical impedance in the middle is hardly ever seen. And as I've just said, inverted V's or bent ends, and anything you do to sort of compromise the antenna to fit in your average garden is apt to push the impedance down. So by a strange quirk of fate, we seem to have a reasonable match to 50 ohms quite often. And as said before, with the coax, use a balun, 1-to-1, balance to unbalance, transform 1-to-1 ratio, or choke type balun is the popular thing. Don't use a voltage type balun, which works in the same way as a old-fashioned linear power supply power transformer, and it means your entire transmit power has got to go through the ferrite core and coupled into the secondary winding. And unless you make it very big and it's working a nice resistive impedance, it's very easy to have things go awry, core saturate, ductance collapses. You do all sorts of horrible things, including radiating harmonics like the clappers. So they were very popular years ago, but people tend to avoid them like the plague, except for special circumstances. There's a picture of a balun that I'm using in the middle of my potentially fan dipole, probably over-engineered. But that's primarily used for 40, 80 meters. Just a string of beads. Yes, WD6, whatever he's, the American amateurs came up with a string of ferrite beads, works fairly well. Multi-band operation. Most of us want to work a variety of bands, preferably using only one bit of wire. A number of the hand bands are harmonically related. Center-fed dipole will work on odd multiples. So a 40-meter dipole will just about work on 15 meters, depends whether you're interested in the CW data or SSB ends. And due to the previously alluded to end effect, which you've only got once in 3 half waves on 21 megs, 15 meters, you might find that if you tune it for one band, it's a little bit out of kilter for the other. So a little bit of juggling for a compromise, and then flatten it with a antenna matching unit. End-fed half wave, say, which has become more popular, we'll work on the even multiples, which is quite appealing to a lot of people. That's if you use the broadband 49-to-1 un. Touch on a bit more on that later. Open wire doublet. It's not usually a resonant length. If you use a resonant length, the feed point impedance in the middle will be sort of low on some bands and ridiculously high on others. So if you're using a 300 to 600 ohm feeder, then there's a tendency to use something a little bit less than the full length of a half-wave dipole. But you do need an antenna matching unit. Widely referred to as antenna tuning units, but they're not really tuning the antenna. Your antenna is still a mismatch, but you're matching, fooling the transmitter into thinking it's got a matched antenna. that might be semantics to some extent. Sorry about the change in font size. My program seemed to sort of change fonts when you want to put more. I suppose for a display in a hall, I would split that up into 2 or 3 slides. The off-center fed dipole, which Roger and 1 or 2 others are great fans of. I think Malcolm's quite keen on his. Incorrectly referred to as a Wyndham by a number of people. The original Wyndham, it dates from something Mr. Wyndham came up with. I didn't look up the exact date, but it's sort of 20s or 30s between the wars. And is basically a single wire feed. It's a sort of almost end-fed semi-random wire, but with a sort of unequal T bit at the top. So it's, think of it as an inverted L with a little, when you get up, the vertical-ish bit gets up to the horizontal bit. There's a bit going back the other way. It didn't really match on any bands, and but back in the good old days, there, very early days, with valve transmitters and tank circuits that could adjust almost anything, there you go. So that's where the misnomer of Wyndham comes from. So it's fed approximately 1/3 of the way along, and you need a special combined transformer and choke thing. It's 4-to-1, 5-to-1, 6-to-1. Debates rage and depends how high off the ground it is, etc., etc. Most suppliers use, I think, a 4-to-1, which quite often is just a sort of auto transformer type thing, and then followed with a choke balun, but all in one enclosure, or try to combine it. This also works on even multiples, same as the end-fed half-wave, so that's quite appealing for 40, 80, 20 and 10 meters sort of thing. You can hang an extra bit of wire off on the a short wire on the long side, and persuade it to work where the 1/3 is, for the starting point, is effectively a 2/3 on bit on 15 meters. The antenna is inherently unbalanced, and this can give rise to both more noise on receive and stray RF getting into all sorts of electronic devices and creating havoc, electromagnetic compatibility issues. And some off-center feds are going to be better than others, and that is really down to just how good and effective the balun bit is. Some of those very expensive, over-engineered ones, you probably do get something for paying extra. Right. There is also, to my mind, I haven't got to the bottom of it yet, a bit of a question mark. You're using, like the 4080 thing, you're using a full wave dipole on 40 meters, and depending on what height it is, that can give rise to big fat nulls for the NVIS thing, and all that stuff. Some years ago, we ran SSB Field Day, and we had a variety of antennas up, and we had an off-center fed and a dedicated 40-meter dipole, and with a switch, and we could switch between the two. And throughout the UK and most of nearer Europe, the dipole seemed to be better than the longer wire, both in S-meter readings and signal to noise ratio, and Jeremy's excellent ears confirmed that. Also, some years back, Phil and James used one stretched out horizontally down at the crest beds for the 40-80 meter AFS, and they seem to be being heard better than most and running, and had a very good score on 80 meters, whereas they couldn't hold a frequency on 40, so they weren't quite sure. Partly propagation. I checked back on those results, and but it did look as though theirs wasn't working that good. Most of the time, in recent, like Windmill coming up shortly and other events, we've used it in a sort of inverted V, or if we're supporting with just one wire and 2 poles for the restricted for SSB field day, it's a sort of upside down W almost, but we're starting to bend things, so probably the null vertically upwards is not so prevalent as when you try and get it a decent height and perfectly splayed out. That might actually be counterproductive in that particular situation. Right, infrared half waves. They've been used on and off quite successfully by some contest groups as verticals instead of a quarter wave vertical or a beam, and generally connected to a sort of homebrew dedicated super low Q, high voltage, high power parallel tuned circuit and used as a single band jobby. Obviously it's twice the height of a quarter wave, and so the high current point is instead of being sort of at ground level is a decent, you know, quarter of wavelength up, which is obviously likely to be a good thing. And certainly feeding it wise is you're feeding at very high impedance points, so it's not that dependent on matching it and feeding power into it on the earthing. But the sort of modern approach is to use the broadband ferrite, as I alluded to. It's wound with 7:1 turns ratio, for those who may or may not realise or have forgotten. The impedance ratio is the square of the turns ratio. The turns ratio is the voltage on current sort of ratios, but the impedance ratio is the square. So 7:1 turns ratio, 7 is 49, hence the 49:1. And well, if you call it 50 and it's 50 ohms feed, that's 2,500 ohms ish, which is reasonable for feeding the end of a half-wave wire. All sorts of debates as to whether it should be used horizontal or vertical. If used in vertical, in particular, it's claimed that a minimal earth or no earth is required, which is possibly true for matching and feeding purposes, and you might believe you've got a fairly efficient thing because you're putting the power into it relatively efficiently, but the actual propagation, the far wave, still depends an awful lot on ground conductivity. So some would say you should use a load of radials, even though, you know, they don't make any difference whatsoever with a half wave on the actual match. Right. And there seems to be, well, we know that 2/3 of the stuff on the internet is absolute garbage, but even trying to filter that out with many 50+ years of knowledge and experience, it's a bit of a nightmare to try and establish whether how well they work. I say some people barely adequate, others say they're absolutely brilliant. If we're going to, some of us, play in John ODQ's field over near Chinner in sometime in June, we might want to try and do some comparisons, stick poles up and string a few bits of wire here and there. And as a PSK reporter, I'm told, is a good thing for checking how you're getting out and all that. So if people are super au fait with that, that would be great, because I'll be on the day completely wrapped up with the physical thing of getting wires and poles in the sky, I think. I spent some money on a big fat choke balun and the 49:1 unknown thing, and that's what they look like inside. These are from Jeff G4 ICD. He was, Malcolm would remember, GJ4 ICD. These are produced for his commercial outlets, which he sells to commercial, military, and all sorts. But he's winding up his business because he's a chap of mature years like myself. Anyway, I've actually got 2 pairs of that. I squandered a load of money. I don't quite know why, but it was a bit of a whim because he was selling off old stock. Multi-band operation. Trap dipole uses coils or tuned circuits, traps to isolate the intersections of a dipole to operate on I bands. And in a classic form with 2 traps, you've got covers 2 bands. Multiple traps can be used to cover multiple bands, but there's all sorts of issues with you know, weight and everything else. Excuse me. If you juggle the L to C ratio of your trap and the precise position of it, you can strike a compromise of using a single pair of traps and covering a number of 3 or 4 or more bands with a reasonable match. I'm not sure what sort of SWR you're going to get. Below 5, I would suggest, which may be still beyond the inbuilt tenor matching units in radios. This is the W3DZZ, but that goes back 50 odd years, and not sure many people use it, consider it now. There is a lot of concern over potential losses in the traps. If you think about it, on the highest frequency, the inner bit of wire, the ends of the dipole are high impedance, and then you're trying to isolate that from the other bits of wire by having a parallel tuned circuit, and you're hoping that's going to be an even higher impedance. Anyhow, you can get losses in the traps, particularly if you know, you have ingress of weather and the things go off. And it's particularly in America, where they run silly power, it has been known for traps to burst into flames, both on wire trap dipoles and in HF beams where they got traps. There are some tricks that can overcome a lot of these problems. Particular one I'm familiar with. We'll go into detail another time. As I've stated there, the late Angus Mackenzie, G3OSS, he was also a very serious audiophile, worked for the BBC, used to publish in Hi-Fi News and God alone knows what else. Basically, you put your traps inboard of the ends and leave dangling ends where it's a more intermediate impedance, so trying to differentiate, isolate is much easier. And the current trend is to use traps made out of wound coax cable, and even have them tuned, not bang in the middle of the band, but purposely tuned off. A 40-80 meter trap dipole might have coax traps between 6 and 6.5 megs resonant. You get all sorts of interactions, so trying to trim the wires to make it work on both bands can be a bit of a pain. But anyhow, so that's another day to go into all that lot. Fan dipole, which I think the serious purist would rate as the way to go. You can connect up several dipoles. I think Roger did a little bit on this. Several dipoles cut for different bands, and if you splay the ends out in a fan fashion, so there's minimal capacitive coupling at the high sort of impedance ends, then you can attach them to common feed point, and they only come down to somewhere near 50 ohms at their resonant frequency. As long as you fan the ends out to a bit, it seems to work. Anyhow, the hot ends, say, is these these. So unlike some other antennas, perhaps a 40-80 meter one, you do the 80 meter wire, you sling up something what you think should work for 40 meters and try and get the ends away, just drop the last half meter to a meter down. Is quite effective. That also means you've got a dangling end which is dead easy to fold back or prune off for tuning. Again, you need a good balun in the middle, ideally. I've seen designs using parallel wires with insulators for 600 ohm feeders, or using bits of 450 ohms slotted and all that. They don't seem to work anything like as well. The efficiency goes to pot and there's more interaction. I think they look horrible as well. Personally, true open wire fed is better. Possibly the most efficient type of multiband dipole, but if we're doing SSB field day under current rules, if you're in the restricted, it's a single wire with no more than 2 supports, and the extra fanned out wires are deemed multiple wires, therefore you can't use it for that. So there you go. It's getting even smaller font, isn't it? You can see that all right. Should be able to if it's filling the screen. Open wire doublet, alluded to before, generally non-resonant. So is the favourite for the top band HF CW field day guys, which includes top band. You don't get top band featuring in SSB field day. Usually around 200 feet instead of 264 feet, with true open wire feeder, and quite often homebrew or automatic antenna matching unit directly underneath the center. So you've got a horizontal wire, vertical drop, and the tuner unit is out there in the field, not by the rig. You can, as I say, use an unbalanced ordinary type matching unit, tuner unit, automatic one or whatever, and then if you put a really good choke balun next to it, that allows the thing to sort of float. It does mean that the chassis would be a bit live, bit hot RF wise, but as long as you don't gear near it, no problems. So as I said there, second bullet point, it's arguably one of the oldest balanced antennas. You know, people have been using it since the year dot. True open wide feeder is incredibly low loss, certainly at HF. It's even usable at VHF, but and you can have a massive SWR somewhere along the line without incurring enormous extra losses. The 300 ohm ribbon and 450 ohm slotted stuff are a bit naff by comparison, although I have to admit they're convenient. This does rate as a single wire antenna for field, I say CW field day, and so it's often about 200 foot long. But all the action on top band, DX wise, is on the Saturday night. Very little is going to be done on 160 meters during the day, so very often they'll drop the ends of their wire and remove links to shorten it to closer to 100 odd feet, which gives less lobes but less nulls and more predictable performance for the HF bands. And certainly going back to the the polar diagram things, the plots, that is quite critical. The keen types will do a full modelling session and then orientate their wire in the field exactly where they want, so that the various lobes hit the bits of the world that they want to talk to. You tend to need to tune it just with relatively short wing QSYing, so it can't be tune it once or twice for the band. Sort of on the back of this open wire fed doublet thing is the 102-foot G5RV, which more commonly these days is seen sold in as assembly with a specified length of 300 ohm or 450 ohm slotted and a lump of coax. It's not that efficient, and I've actually had both out in my garden and proved it, that it will always perform better if it's run. I ran a 100-foot doublet with twin wires feeding right into the window. Just trapped them in the window frame straight into the shack, and that absolutely knocked spots off of the G5RV with the 300 ohm ribbon and coax, and that is how Louis Varney originally designed it. It's a sort of extended double ZEP, I think they describe it as, on 20 meters. So that's got a narrow figure of 8 with gain, which is what Louis Varney designed it for specifically, and then found that it actually worked terribly well with a bit of tweaking on various other bands. The later 300 ohm ribbon sort of incarnation, he generated to I forget what job he did, but he toured the world in his work, and he could wind up a G5RV with the ribbon feeder and a bit of coax and stuff it in his briefcase and sort of with carry-on luggage. And he had a little tiny CW sort of two or three band QRP transmitter sort of he'd shove in his main bag. But I was privileged to hear him present many years ago, late 70s, I think, in the Aylesbury Club. But he's long since gone silent key, of course. Verticals, I don't want to go into depth here because you could spend hours on verticals on their own. Most commonly a quarter wave vertical, which potentially can work good for GX, good low angle, almost nothing straight up. So if you want to work the UK, forget it. Omnidirectional. Efficiency is massively dependent on the earthing system that it has to work against, and just a single spike in average ground, as I say, is diabolical. Even if you get a passable match, I mean, it's half a dipole. So in theory, it's 36 ohms, which is about 1.5 to 1 SWR. If you get a 1-to-1 SWR to 50 ohms, and you say, oh, isn't it wonderful? No, that means you've got a good match because you've already lost 20 to 30% of the power. You're warming up the earth. So you'll find if you put more and more radials, the SWR will steadily get worse and worse, but you will actually get out better. And it's not uncommon to see as little as 10 to 15% efficiency. So 100-watt transmitter, that's almost QRP, 10 to 15 watts. And some of the cynics often describe verticals as irradiating equally poorly in all directions. Saying the high current point, the bit that radiates most is down at ground level. Houses, garden sheds, particularly if they're modern tin ones, any other bits of extraneous metal, it's going to completely knacker the takeoff. But they do work very well, sort of dangled by the beach, dangling in the sea type of thing, where you've got a very good ground conductivity. just a little bit I'll go into. If you want to jack up the length towards about 3/8 of a wavelength, it then looks inductive and a bit higher impedance. So if you shove in a capacitor, a series capacitor, to tune out the inductance, you then get back to a much better match. You're not quite so dependent on an extremely low impedance earth, and it physically raises the high current point up in the air a bit. That's what I've got at the bottom corner of my garden. It's a quarter wave, well, it's almost 3/8 wave vertical for 40 meters and inverted L for 80 on a common feed. I just note there the DX Commander, which I think Ant Scott and a number of people use quite successfully. That's really a nest of quarter wave verticals. But earthing is key. I think there's some single elevated radials used, but that's a little circuit board with ancient mica capacitors that are rated at lots of volts, with some high value carbon bleed resistors to just discharge static across them. That's down on the post at the bottom of my garden, and that's it in situ. And that is feeding an alley scaffold pole for 40 meters with a bit of fiberglass pole in the bottom to insulate that. And I've got bits of insulation and keep the scaffold pole RF wires floating. And then the thin grey wire you can see coming off the second terminal up. I made tapping points to be able to play. So that seems to work quite well. Right, more specific antennas that Roger certainly didn't touch on. The CobWeb. I was very skeptical for ages and eventually gave it a try and was pleasantly surprised. It's very compact, multi-band HF end, horizontal HF antennas. I've likened it to a nest of halo antennas common on 2 meters, 6 meters, etc. Square halo with a common sort of feed point. Mine seems to prove quite effective, even at quite a low height. And the most amazing thing is it's surprisingly immune to detuning from other wires or bits of metal or anything else in the area. So theory says it's got to be 2.5, 3 dB worse than a dipole. But if your dipole's not in the clear and is, slightly detuned by all sorts of other random bits of wire, which happens most of the time because wavelengths away or more if it's not going to do much, and that's never going to happen unless you've got the odd acre or two of ground. And it seems to be that the fact that it's bent round in a square with the ends close, most of this sort of stray coupling, fringing is between the ends. I mean, think back to school days of a bar magnet, a piece of paper, and sprinkling the iron filings on and tapping it. You can follow the lines of force. Well, most of it's going to be between those ends, so it appears to become less upset than a conventional dipole by other stuff. Right. Each dipole loop, there are variants. I mean, James has got one made from a single wire, but it'll have a low impedance, possibly 20 ohms-ish. You can use parallel those up and use a 4-to-1 balun, and it'll work quite well, but they tend to have quite narrow bandwidth. The true CobWeb, the wire bit around the spreaders, uses elements made of basically twin speaker wire. And about 2/3 of the way out, you cut through the insulation, twist the ends together and solder it. I could never quite get my head around that. It seemed like creating a folded dipole and then having an extension on that, but it is an extended T-match. I intended to do a drawing, but because they use T-match on some beams and things, but anyhow, I'm sure it's an extended T-match and it gives rise to a much broader bandwidth. So 20 meters and you know, going up in frequency, you can cover most of the bands, well, except 10 meters, which is technically 2 megs wide. Right, and yeah, the last point there of what I've already said, and the purists get quite sniffy about the fact that the single wire cobwebs, so-called, are not true cobwebs. So that's my concocted lightweight one, lying on the patio there. That's just plumbed up for 10, 15 and 20 because I use it for contests. The 12 meters, 17 meters, etc. are contest-free zones. 17 meters during the previous Sunspot cycle was my favorite non-contest band, but I did have a hex beam up at that time. Again, very lightweight homebrew construction, and the main hexagonal hub, instead of being a big plate of alley, I used marine pry, and it turned out to be not that marine. It lasted for about 3 years, and then the weather got in the end grain and it disintegrated on gale. It all collapsed on me. But I've used 4 out of the 6 spreaders. One broke, I had 5, so I've shortened those, and bingo, I've got a cobweb. And the whole assembly weighs less than 3 kilos. Oh, aided by the fact that I use some copper coat plated aluminium speaker wire. So the old skin effect thing, the fact that it's copper cores, it doesn't matter a monkeys. There's me pretty lightweight hub center. I've chopped a bit off the bottom end of these flagpole type, you know, fishing pole things, and also a bit of thick heavy duty heat shrink sleeving, and that sort of they just drop in. I can take that out of its bag, fish it down from the loft, take it out of its bag, assemble it, and be bolting it on a temporary mast in sort of less than 15-20 minutes. As the feed end, fax goes in there, and there's a couple of bits of sort of circuit board stuff to fan out, and as you can see, there's 3 of the lots of wire there. When it's up in the sky at about 8 meters, which is surprisingly effective. So even my feeble frame can slap that on a push-up 10-meter mast and get it most of the way up on a temporary basis. Incidentally, in the background, you can see by the chair to the left is one of the bits of pole, and the to the right of the summer house behind the little bit of shed, that's my 40-meter vertical thing, which is all going through planning stuff at the moment because of the bloke next door who whinged. Another shot with it sort of up in the air. Right, touch on this. G7FEK, no personal experience at all. Phil, M0MVS, has found it pretty successful. It's essentially 2 inverted L's. I'm not quite sure how high it goes, only about 8 meters, I think, before the... and it's the original version constructed from a vertical bit of 450 ohm ladder line, and then a couple of wires going out in opposite directions at the top. Third point there, in original form, I think it was intended to have just one elevated, i.e. tuned radial per band. Once you lay your radials on the ground, you get such sort of massive loading, they're not tuned anymore. So, you know, the more the merrier, and various lengths is the order of the day, with ground or buried even radials, but elevated, you can sort of get away with a single one, ideally 2 per band as a minimum. But say fillers, substitute, well, added, I think, rather than substituted. Massive earthing system. I think most of his back garden is wire mesh that's sunk into the grass now, so he can happily mow over the top. I think it was a garden centre and a load of chicken wire or something similar, but we need to talk to Phil about that. I did see an article where a guy used a bit of PC simulation, emulation software, and had a tinker, and he effected an improvement and easier to tune, less interaction between the two bands, if instead of running the vertical bit out of 450 ohm ladder, you splayed it out from the ground upwards, half of a fan dipole. And that's basically what I've done with my thing. So the 80 meter bit is just a bit of wire going up, and it is best part of a meter away from the 40 meter bit at the top. So I say even 100 to 200 mil separation makes a big difference. It seems to make complete sense to me, that. So I say it's more like half a fan dipole. You've got modest height, which is convenient to a lot of people, part vertical, part horizontal, and seems in practice to be not a bad compromise for a bit of DX and you know, a bit of the 80 meter CC things where you want into G stuff. So we need to nobble Phil some more on that, get more details if people want to pursue that. Right, say possibly the 10th of June, or if the weather looks foul with that approaching, the 24th, Saturdays, both Saturdays. We plan to decamp to the QTH of John, G0DQ. It's a little bit in no man's land, Emmington, sort of between Chinner and Tame. It sounds a long way off, but for a lot of people, I don't think it's going to be any worse than going to Brill. And I'm after input on what we're going to put up. At the moment, I've got a feeling that we might be able to put up 4 poles in a square and string 4 different wire antennas between them all, and try switching between them and practical comparisons between conventional dipoles, end-fed half waves, off-center feds, and all that stuff. Yeah, I can easily do my CobWeb and all the rest of it. John's field is, I would say, larger than the field out at the back of the meeting hall at Ashley Green. And again, I mentioned there the PSK reporter thing. Anybody who's into that, you know, much appreciated. So that is it.
Yeah, one thing you did comment about as you were going through and talking about the verticals was halfway vertical. You question whether it needed radials or not. I used to have, until it sort of detached itself from being a complete antenna. I used to have an R5 Cushcraft vertical, and that's effectively a half wave with traps in it. And what they used then was what was not then called an UNUN, but was an UNUN, which I've still got. And they used 4 short, not really radials, just to counterpoise, presumably to effectively tune the transformer against something or other, and they just came out at the bottom. you know, as the other part of the leg, and that does have the advantage of putting the current antinode higher up because it's halfway up the antenna, and gets away from that problem of the quarter wave vertical being, you know, ground based and warming up the ground.
Yeah, yeah, that's I'm sure that's reasonably effective, but I know some people will argue that it's how good a signal you put out is still dependent on your ground conductivity.
Yeah, I think it is. And I think the other thing is that having lots of traps means that it's lower in efficiency because you're losing a lot of power in the traps. And if you just made, you know, a single or dual band vertical on the same principle, it would probably perform much better.
Yeah, well, I think that's absolutely true. So you could lay out loads of, if when you got that Cushcraft halfway vertical, multi-band vertical up, and it'll work quite good. And if you laid out loads of proper radials actually on the ground, you'd probably find it would do absolutely nothing to the feed impedance. But if you were able to measure received field strength, you know, hundreds or thousands of miles away, you might find the more metal you put on the ground, the better it got. I don't know whether it's an R5, R7 or what it is, but it is a Cushcraft vertical, same or similar to yours. Chris or CRF has got over at New Longville. And some 5 years ago or so, I took my lightweight homebrew hex beam over there. I left it, we were doing some tests. I was doing some, you know, put it up temporarily in tuning stuff. And I left it with him, left it up on a temporary pole for a week or two. And he did a number of comparisons. And 9 times out of 10, it was between half and 1.5 S points better than his very expensive Cushcraft vertical.
Yeah, I think
because the hex beam had it really didn't, to first approximation, you know, didn't matter what the ground conductivity was. It might alter it by 10 to 20% tops, whereas it has a dramatic effect. You know, as I say, these DXpeditions, they stick a simple vertical sort of literally in the sea. You know, they plant it on the beach at low tide, and so the bottom is literally, you know, in a foot of water when the tide comes in, and they work the world. And another sort of DXpedition will put up 60-foot beam, sort of a beam 60 foot up, you know, half a mile inland, and that's no better than the simple vertical sort of literally planted in the sea. I mean, my friend Stuart, G3RXQ, he used to be in Aspley Heath, I think it was, up the top of the hill from Woburn Sands. Now, it wasn't one of his smarter moments. He spent a lot of money on a step IR motorized vertical, multi-band vertical, which uses a sort of half a folded dipole, I think, you know, and all that. And he was incredibly disappointed with its performance, and his sort of 180-foot doublet seemed to outperform it all the time. But then, you know, it's Woburn Sands. Sand is not a very good conductor for earth plane. His true earth was probably through a very lossy insulator and maybe some, you know, 10 to 20 feet down in the ground.
Dave, just a quickie. You didn't cover sort of homemade mag loops. Have you got any thoughts on that?
No, it's not an area I've often sort of vaguely looked at it. Some people find them very good. They're great for suppressing noise on receive. if they're going to be efficient, they're going to be incredibly narrow band, such that you just move one SSB wavelength away from your tune frequency and you've got to retune the loop. If you've got a very sophisticated one with remote motorized tuning, that may not be a problem. But yeah, I have tried recently to combat noise on the low bands, 40, 80 meters, a complete loop of wire quite close to the ground. In fact, again, my friend Stuart, he's up in Lancashire now, and he's got about a 20-foot square loop, and his wire is only about 6 inches to a foot above the ground. And even working some significant distance away, Europeans on 40 and 80 meters, it's a lot of dBs down, but it does give him better receive performance. And I mean, he's got his 3.5 acres, and he's, as well as dipoles, he's got his phased vertical pair for 80 meters and a 4 square for 40 meters. So, you know, he's a bit serious on the antenna front.
Yeah.
He's tried all sorts of flags,
Agreed.
pennants and other things, but this untuned loop he's found is well, it's more robust and weather resistant, and you haven't got to worry about tuning it. And yeah, that's his current flavor, if you like.
Okay.
But yeah, mag loops, another topic for another time. And somebody else maybe, or I've got to do a lot of homework.
Yeah, so I've put a random wire, which is 42 meters from my house to the bottom end of my garden. And that's obviously from the pitch of the house down to the top of the shed. Well, it actually goes over the top of a tree branch. So it's probably about 8 meters high, 8 meters up. And the wire itself in open air is probably 36, 38 meters long. And then it drops down from the tree, and then actually it has to wrap around itself on the back of the shed a little bit into a 9-to-1 unum. And then the earth side is straight into an earth stake into the ground behind the shed. And that is working tremendously well, actually. I was quite surprised that's been as effective as it has been. So I've got picking up strong signals from America and so forth on 40, 80 and up. So it's quite impressive, really, because it was just sort of an experiment to see if this is going to work any better than my vertical, which is hidden in the trees.
Is that 42 meters or 42 feet? Is it? I don't know.
Meters, 42 meters.
Right, that's quite a long bit of wire, isn't it?
Yes.
But it's been deemed to be a sort of
medium
impedance on all bands, hence the 9-to-1
yes
thing, which is 3-to-1 turns ratio, 9-to-1 impedance ratio.
Yeah.
You
tunes up
might
perfectly.
find it works better with without effectively your loading coil wrapped around the tree or whatever near the feed point, or if you can substitute a loading coil sort of towards partway along towards the other end or something, you know, change things. Also, it might be worth, if you've only got a single stake in the ground, it might be worth doing a bit more there, just chucking some wire out on the ground, or even I mean, at the base of my vertical thing, I've sneaked in some radials across the sort of paddock area on the land out the back. Yeah, and me and a friend sort of just, you know, went over the fence and with the aid of a spade, cut a slot and shove a bit of wire in, etc. So the lady with the cider apple orchard there doesn't realise she's got about 4 or 5 radials splaying out across it.
That's not bad,
and that did seem to make a difference. I mean, I have successfully worked a number of, mainly East Coast, granted nothing super DXy, but I can work 80 meters phone USA stations during the winter months,
Okay.
mainly during morning and evening grey line, you know, dawn dusk sort of thingy. But and whereas the dipole, well, you can barely hear the stations there. Flick over to the inverted L, or particularly on 40 meters where it is purely vertical, and that's that works a dream. It's, you know,
What sort of power are you using there? Are you
Oh,
using
well, if you're
400
trying
or-
to work the stateside and you know there's others calling, I
Yeah.
do reach across and flick the switch of the KPA 500, so it's full legal or
Yeah.
thereabouts, you know.
Yeah.
But no, you could bang one or two more stakes in the ground. I think I've got 5 or 6 spread around about
Okay.
half a meter out,
Yeah.
around in a loop, and they've all got bits of wire going into the base, the Earth's central Earth point, and also a strap of copper or aluminium or whatever, sort of connecting all the way around. So, you know, the more mass in the ground, the better. Another trick, if you've got trying a whole multitude of different earthing systems, odd stakes, odd bits of random length, radial and all that, there is a school of thought which says if you bunch the lot together and then have just 2 or 3 turns of wire, and then put that into your sort of tuning thing as the earthy end, you can argue you've put a small loading coil in, you've raised the feed point sort of electrically and physically, and that's off the ground. And also, if any of those radials, if they are slightly above the ground and they're trying to be resonant, they're sort of fighting each other, this common sort of inductance, once everything's bunched together, tends to sort of flatten that out. Yeah, that picture you can.
Oh, so you've actually just
I've got a bit of the red wire is effectively a tiny bit of base loading on the 40 meter vertical, and at the bottom of the box you can see it's just really a sort of turn and a half of, that's it, Malcolm, of ordinary mains earthy type wire going to, there's one bit, it's actually aluminium angle, bit of extrusion that I've hammered into the ground. But I've got about another 5 similar bits, that say splayed out in a semicircle and all strapped to each other and then sort of buried with earth over it. I've been fascinated by antennas, or as they used to be known, aerials, for donkey's years. But everybody I know who went to university and did antenna theory as part of their university training found it an absolute boring groan. But of course, and when you get deep into all the sort of maths and the calculus and Christ knows what else, and I'm the basic instinct of rule of thumb type man.
Dave, look, if you stuck your that pole, I see you've got it insulated at the bottom. I don't know what's on the top of that pole, but could you not put the pole in the ground as part of the earth?
Yes, because I wanted to feed it. The pole is a physical support, and it's the wire, if you like.
Okay.
And it goes through one of those or a couple of those mica capacitors, and then to the center of the coax. Anybody else with questions?
I've got a couple of delta loops, and they work reasonably well and are quite easy to mount. They're just a triangle with the apex at the top, so you only need one high support, and then they pan out, and you feed them with a little chunk of 75 ohm coax connect as a sort of stub, and then connect it to 50 ohm, and they both work quite well. I've got one for 40 and one for 20.
Right. Yeah. Yeah.
meters.
If
And,
you do one for 80 meters, it's getting a bit physically big, isn't it? You need a
it would
quite a
get
large
quite big.
support.
Yes. Yeah. No, I think that probably wouldn't fit in very easily unless I bent it round corners. And I've also got an inverted L with an remote auto ATU at the bottom of it, and some elevated radials, and that's quite useful because it loads up on basically all bands, except it doesn't like top band very much. It's probably not brilliantly efficient, but when I tested it against a DX Commander with about, I don't know, about 30 radials, not terribly long, virtually on every band, the inverted L was better than the DX Commander, which is probably not others' experience, but it was mine. So the DX Commander got taken down. The other little aerial I've got was in practical wireless. I had a half-size G5RV up on my garage Apex, and that broke. And in practical wireless, there was quite an ingenious design for a dipole, because this chap had worked out that 7 wavelengths on 4 meters was roughly the same as 5 wavelengths on 6 meters, and about three wavelengths on 10 megs or 30 on 10 meters.
Yeah,
and it also runs on 10 megs, so it's it gives 4 bands, and it's really quite ingenious, and on 10 meters it beats my sort of end fed that's a lot higher and longer and in the clear.